Welcome back to Open Source Databases on Microsoft Azure course in Microsoft Virtual Academy. My name is Oğuz Pastırmacı, and I'm working as a technical evangelist in Microsoft.
And I'm Damien Caro, Technical Evangelist Manager at Microsoft.
So in this third module, we are going to see how we are doing things in the background about high availability in Azure, and also how you can do things in Azure to provide your application or your database with a highly available environment. Let's take a look at what we are doing in the background in Azure. So we have a thing called availability set. If you check our SLA agreement, you can see that we are asking you to use at least 2 virtual machines per application. And the reason behind that is from time to time, because we are doing maintenance inside our data centers, we need to restart our physical servers. And if you don't create an availability set, we wouldn't know that these 2 or more virtual machines you have created are actually running in the same application. So what you can do is, when you're creating a new virtual machine, create a new availability set and add your virtual machines to that particular availability set. You're basically saying Azure that, okay, these 2 virtual machines, they are in the same availability set, so make sure you do not put them in the same server, for example. If you need to restart a physical server that this virtual machine is running on top, make sure the other virtual machine is running in a different physical server, and that physical server is not being restarted at the same time with the other physical server. So let's take a little bit more about the design. So we are running a data center, so obviously we have physical machines, and we have a power unit rack switch in our racks. So when you create an availability set using 2 or more VMs, you're basically telling Azure, as I mentioned, just put these virtual machines in different physical locations. We also have different concepts called the update domain and the fault domain. Update domain means, as I mentioned previously, do not restart this virtual machine at the same time. Do not restart the physical servers that these virtual machines are running on top. For example, I have 4 virtual machines in the slide. 2 of these virtual machines are running in the web tier, and the bottom ones are running in the database tier, MySQL virtual machines. So I created different availability sets for each of them. In the orange availability set, it's the web server availability set, and the green one is for database servers. And of course, these virtual machines are, since they are in an availability set, they are running in different racks of hardware. So that also means they are running in different fault domains. Fault domain means if there is any problem, any hardware problem, any power problem, anything with the maybe the connection problem, these virtual machines will not be affected at the same time, since these virtual machines are actually running in different physical environments. An update domain means, again, these virtual machines in the same availability set will not be restarted at the same time. To prevent any outage, you may have a web server and a web application running in that virtual machine. So you, of course, don't want these 2 virtual machines to be restarted at the same moment. It's really straightforward to create an availability set. You don't need to have any technical details. You basically just set a name and decide which virtual machines will be part of this availability set. You can either create a new availability set, or you can just use the availability set that you have already created. One very important aspect of network high availability is, of course, creating some alternate paths. So in Azure, we are giving you, again, options. You may be having a point-to-site VPN. So for example, the people working in your company, your employees, can use a simple, usual, common VPN connection to connect to the Azure data center and the virtual network of your virtual machines. Or even better, you can just use your VPN device in your office to create a VPN connection, a site-to-site VPN connection between the Azure data center and your on-premises environment, your office. And of course, we are giving you the option to use load balancing. You have two options. We have two types of load balancing in Azure. The first one is called external load balancing. It's pretty much what you can expect. There's a load balancer in Azure data center, and you put your virtual machines behind this external load balancer. So any request coming to port 80, for example, will be balanced between different virtual machines. You can use ACLs, client affinity, you can create a custom HTTP probe, etc. But you also have different ways. So the first way is, again, external load balancing. So you may have 3 web servers, and the traffic coming to these 3 web servers will be load balanced by the Azure load balancer. But you can also do this internally. What I mean is, let's say you have 2 web servers running in Azure, and also you have 2 database servers running in Azure. So you can just set that these 2 web servers are also using a load balance path when they are trying to access the database servers which are also running in Azure. You can see a sample reference architecture. So there's a load balancer for terminating the SSL traffic. It just forwards the requests to the virtual machines in web tier. But then these virtual machines running in web tier are also using an internal load balancer. So their requests to the database virtual machines are load balanced and not just using one single database virtual machine. You can even add your own on-premises environment into that equation. Again, if you create a site-to-site VPN connection between your on-premises network and Azure, you are able to use that internal load balancer to give access to your on-premises environment to the load balancer working internally. But customers, they also come with us with a different type of request. They say, okay, I can create a VPN connection, site-to-site VPN with IPsec, but still, this means I will be reaching to the resources in Azure using the internet connection. What if I want to have a dedicated, separate tunnel coming from my company and ending in Microsoft data centers? There comes ExpressRoute. We have a service called ExpressRoute. It's basically an MPLS circuit between the Azure data center and your on-premises environment. You can have a dedicated pipe for you to access the resources in Azure data center. And there's a very good thing going on at the moment. Until June, I guess, end of June, you can use ExpressRoute for free. You can just check Microsoft blog about getting information about this offer, or you can just talk with the Microsoft contact in your company, but you can just apply and use ExpressRoute for free until end of June.
So can you do ExpressRoute with anyone, or is there any elements that our customers, our audience should know before they start looking at ExpressRoute?
We are working with our partners about using ExpressRoute. So companies like British Telecom, Level 3. So depending on the region your company is, you need to talk with these partners. So we are not just using our own fiber, Microsoft fiber, to reach out to your office, but we are rather using respected companies with a very good infrastructure to provide you with that kind of circuit between your office and Azure.
So actually, we haven't jumped into the telco business. We are relying on partners to provide the network connectivity to our data center, and our customers can work with those partners to actually implement the MPLS connectivity.
Exactly. It saves you from trying to figure out how the BGP settings should be, how should we routing this traffic to Azure. Since we are working closely with these network partners, telco partners, we know how to build up this circuit between your company and Azure, and you don't have to. You just apply and you say, okay, I need this MPLS circuit. I need the speed of 10 megabits, 20 megabits, whatever, and the engineers from Microsoft and the provider company will just set it up for you. You can also use ExpressRoute for a topology like this, for providing high availability and also disaster recovery. So let's say you have offices in London and Amsterdam. So you can use ExpressRoute to connect these resources to the North Europe data center of Azure and also the West Europe data center of Azure. So you can just use an active-active topology in one location or active-active also in the second location. So it really provides you a very flexible way to access to resources in Azure data centers, and also it's an easy way to create an HA and DR possible environment for your resources.
So basically, if we consider open source database as of today, we could run one or multiple nodes in a primary data center, use this connectivity and replicate the data to a different data center, and using the network that has been established between those two data centers to replicate the data and make sure we have a disaster recovery in a different environment.
Definitely. That's the main idea behind using that kind of topology. And security, of course, is important when you are trying to deploy, especially databases in your premises, whether it's working on premises or in the cloud. We have the feature called Subnet access control lists. So you can see that I have 3 tiers and I have 3 separate virtual networks here. And I can decide on the rules that how these tiers, how these VNets will be communicating to each other. Another cool feature we call is force tunneling. Especially for database servers, we don't want these servers to be exposed to internet directly. So you can basically configure Azure, the virtual machines, the database tier virtual machines, they should not be accessing internet. When they try to access the internet, just force their traffic to my tunnel between the connection, to the connection between my on-premises data center and Azure. So they do not access any internet resources, which of course very important because the general types of attacks like SQL injection, man in the middle, pass the hash. It's a very good thing to think about.
Yeah, you want to protect your database systems as much as possible and isolate them from internet. But actually, I have a question regarding that. So we talked about the database. We basically isolate them. We have the geo redundancy. We have networking. Isn't Azure providing some solution for that?
What
natively in Azure? Like redundancy and geo-replication?
Of course, the next slides I'm going to cover how we can have redundancy about storage part. So we can have, I'm talking about now the network redundancy part, but as you mentioned, having a redundant storage infrastructure is also very important. So what we are trying to avoid is to have a single point of failure. Because no matter how good your application is, the design, Azure resources access, etc., if you have a single point of failure that would just prevent your application from running, it doesn't make any sense. So here's the answer to your question.
Aha.
We have storage durability options. So basically we have 4 different options. The first one is locally redundant storage, LRS. So it means, this is the default configuration, by the way. It means we are storing 3 replicas of your data inside a single region. So no matter you like it or not, you want it or not like you will like this, of course, we are keeping 3 replicas to prevent anything happening from like a data loss, because at the end of the day, there may be some disaster, natural disaster, flooding, fire. I don't want to name all of them, but you need to have some sort of redundancy by default.
So, for example, if a disk fails, and that happens, it happens every day, if a disk has an issue, we actually, in our data center, have 2 additional copies of the data that are on that disk. So basically, we will take that VM running on that disk and reattach the VM to a copy of the disk, which will bring, of course, an interruption of service, because we need to restart the VM to reconnect to the new storage, but we will still give access to the data.
Mm-hmm. And also in some geographies, some countries, the legal implications say the replication shouldn't be leaving the region itself. So in that case, you should be using local redundant storage, because in the next slide, I'm going to show you that in geo redundancy, we are replicating that information to a different region. And if the law in your country prevents this, you should be using a local redundant storage. Another option, another scenario is that your application is already doing some kind of redundancy in the application level. So in that case, you wouldn't need to have a geo redundancy storage, because, for example, you may be using SQL Server's clustering ability, so you are already replicating the information between virtual machines, so you wouldn't be using any geo redundancy option. The second option is called zone redundant. So we are again storing 3 replicas of the original data. The difference is this provides you additional durability to protect it from zone failures. So we have the design of our data centers are based on zones. So even there's a problem concerning that zone in our data center, the data replicated by zone redundant storage will be there, so you won't lose any data. And we have, of course, geo redundant storage. That means we keep 3 replicas of your data inside a region, and we replicate this to a different region, meaning you will have 6 replicas of your data between regions, in different regions. Of course, this is giving you a very good opportunity to recover your data in case any disaster happens, but you need to consider that this operation is not synchronous. So when you write the data to the disks, we take this data and replicate it to another region asynchronously. So if your application needs to have a synchronized replication, you should be looking at other options. Maybe use a local redundant storage and perform this synchronous replication in the application level.
And can you read the data that are coming from, can you read the copy, the geo-redundant copy?
We are not giving you access to these copies because we want to make sure this data has consistent, in a consistent state. So what we are talking about, it's a disaster in Microsoft side. So it's not like, okay, my virtual machine crashed, I need to have this information, can I access to the disks? It's not like that. It's for a disaster recovery situation. So you should be taking backups, you should be providing an application level redundancy if you need it, but that doesn't mean that you can just call Microsoft, okay, I need to access these replicas because one of the IT guys accidentally deleted some file in my virtual machine. That's not work. That's not going to work.
Okay.
So in the slide, you can see the geo replication pairs. So that means if you put your data, for example, in North Central US data center, we are going to replicate this to South Central US. These pairings are predefined, and you cannot change this. You cannot decide about what is the target pair for replication. Mainly, this is because of being able to, obey the local rules, especially for the European Union rules. So the data doesn't leave Europe in that example. If you put your data in North Europe data center, it will be replicated to West Europe. It doesn't leave the European region. It doesn't. You don't replicate your data to US, for example. And the final option is called read access Geo Redundant Storage. It's Geo Redundant Storage, but the only difference is the data in the secondary location, you only have read access. So it's not a read-write access, you only have read access. And of course, the cost of these options will change depending on how many copies are there. Do you want to have a geo-redundant solution, a local redundant solution? So the more geo change in the replication scheme, the more money it will cost. You can think of like this. So I'm going to do a very quick demo about deploying a MariaDB MySQL cluster on Azure. And before that, let me show you by going to my virtual machine here. So I have used the step-by-step instructions, the tutorial in Azure website to run this demo. I did this because if you want to do the same, you can just follow the instructions here. And another cool thing, you can see that this tutorial has contributors. It's not like someone from Microsoft just sat down and wrote these instructions. This documentation on Azure is on GitHub. So you can just go edit this tutorial if you like. If you think that one part of the tutorial is wrong, or you want to add some more, a better explanation, you can just edit this. So I'm not going to, of course, do the virtual machine deployment part, creating the SQL cluster part, but I will just show you here. So let me show you the design first. The design is like that. So we have 3 virtual machines running MariaDB, and they are behind the load balanced endpoint. We are running CentOS virtual machines. We have storage accounts, and each of these virtual machines have 4 disks, which are striped by using RAID 0. And of course, these virtual machines are in an availability set, meaning they will not fail at the same time in case anything happens in our data center. And in the left-hand side, you can see the name of our cloud service. So basically, you will have a single point of access. It's mariadbha.cloudapp.net port 3306. And the Azure load balancer will take care of the rest. So it will just start sending the requests by balancing the request to that virtual machines running in that topology. So I will also show you about using the cross-platform CLI. All these one-liner accounts you see here are cross-platform CLI commands. So, for example, right now we are creating an affinity group called MariaDB cluster in the North Europe region, and we name the cluster as MariaDB cluster. So it's pretty straightforward. And after deploying the virtual machine, we deploy one virtual machine as a template and use this virtual machine to create 3 additional virtual machines. So you can see right now I'm adding 4 disks and creating a RAID configuration.
So each disk will bring 500 IOPS.
Exactly.
Maximum.
Exactly.
4 disk means you will have 2,000 IOPS, if I count correctly, on each of the virtual machines.
Exactly. And after creating the virtual machines, of course, the rest is basically MySQL and Linux. So right now, you install AMD ADM to create the RAID volume. And after that, of course, you need to install MariaDB. And after you install that, you have to do some tips and tricks for fine-tuning. So you can just follow this tutorial, step-by-step instructions. And in the end, you will have a 3-node MariaDB MySQL cluster up and running. So I have this virtual machines here, MVA MariaDB 1, 2, and 3, and they are working in a cluster. So when I connect to MariaDB 2 here, I can just check that my cluster is running by connecting to the cluster. Enter the password, and I'm in. So what was the name of my, I think it was TempDB. Okay, I don't remember the name of the DB, but you can see that the cluster is connectable, and you are going to use this MariaDB, MVA MariaDB ha.cloudapp.net as your endpoint.
So the name that you have, the MariaDB cloudapp.net, is actually the external endpoint. And the external endpoint has to be exposed to internet. So talking on the Azure architecture, you need to consider which port you want to expose and who you want to expose the port to. That port can obviously be exposed behind the load balancer, and that's the architecture that you have created. So the name that you're using is actually the external name, and that's an important thing to consider.
Exactly.
You're actually using the MySQL command to connect through the external port, even though you're connected on an internal VM.
Yeah. It's the name of the cloud service. So when I go to my cloud services, you can see here it's MVA MariaDB HA. And if I go to the details, you can see that the public virtual IP address and deployment name, that kind of information when it's created. And more importantly, instances. So I can see that my 3 virtual machines are running as a part of this cloud service. So since they are behind and load balancer, so the traffic coming to MVA MariaDB HA cloud service will be load balanced using these 3 virtual machines. You can add a 4th virtual machine. You can remove the virtual machine. So
you can basically add as many VMs.
Exactly. You can
cluster.
easily scale out or even scale up if you need to. And you can even automate this. So you can just create a rule like check the average CPU usage of my virtual machines, and if you see that the average consumption of CPU goes over 80%, just start a new virtual machine with the MariaDB cluster node installed. It's really flexible, and you can see that all of these virtual machines are in different update and fault domains. So I basically have a highly available database cluster running in Azure. Once again, this tutorial is very straightforward. I encourage you to go through it and create your own cluster. We have other documentation like creating a MySQL cluster using DRBD, CoroSync, and Pacemaker. It's also documented. Just go to Microsoft Azure website and search for the keyword you want to have more information, and you can have many documentation about, for example, MySQL. This one is the one I'm talking about. You can create a cluster using MySQL, CoroSync, and Pacemaker. So that sums up module 3. So we have covered how we can create redundancy for our network, for our storage, and how we can use this redundancy to run virtual machines on top of this redundant infrastructure in Azure and have a very highly available web application, service, whatever you like is running. In the next module, we are going to talk about how we can manage and monitor all of these services, right?
Absolutely. Stay tuned for how we manage, how we monitor, how we use third parties to deploy and configure all those systems.